Okay, let's get going. So what are we going to do today? So in today's lesson, we are going to talk about horizontal shifts of trig graphs. Okay. Now, in the previous lessons, we have done, what have we done? Let me show you all the different types of transformations we can do for trig graphs. So if we look at the full set of things that we can do to a trig graph to change it, and I'm using the sine graph as an example, we discovered in, I think, lesson 2, that the amplitude change is this number in front. And the default setting is for that to be 1. If you change that to a 2 or 3, it stretches the graph vertically. Then we also spoke about this plus Q, and this can shift the graph up or down. And then in the last lesson, we spoke about changing the number in front of the variable, which we said change the period of the graph. Now, today, we're going to look at the last change that you need to know about, which is something called the horizontal shift. And if we have to draw like the standard form of a trig graph like this, these are the 4 changes you need to know about. However, if we just focus on only a shift horizontally of the graph, it would normally look like, say, something like that. So if you see a trig graph that is y equals sine x plus 20, this is an example of a sine graph that's been shifted. Now, what I want to know from the class is, tell me in words or in typed answers, what has happened to this graph y equals sine x plus 20 when you compare it to the basic graph y equals sine x? Who can tell me? Put your hand up or put it in the chat. How have things changed, left, right, or up or down, by how much, if we focus in on this change here? Who knows? Or who thinks they want to have a go at this? Pop those hands up to have a go. Points for bravery, no points for correctness. Okay, so we have a Dudu has said horizontal shift to the right by 20, and Mbali and Zanele has said move to the right by 20. Haha. Okay. Who else? Anybody else have an idea? Are they correct? Does anybody disagree with them? Does anybody agree with them? Maybe we should. Mbasa says to the left by 20. Kutuano says to the right by 20. So there's a little bit of debate to the right by 20. Aha. Now, if we think back to earlier functions we did, like the straight line and the parabola, do any of you remember me saying that the horizontal shift, it always seems to move in the opposite way to what it seems? And so actually, what's funny is that if you put x plus 20 into this graph, even though it seems like it should go to the right, this actually shifts the graph 20 degrees to the left. And so when we deal with a horizontal shift, I want you to be aware that a horizontal shift always moves kind of the opposite the way that you expect. Now, in order for us to see this, I'm going to do an example with you now, but I want you to bear that in mind. When we deal with the horizontal shift, if you see a plus 20, it actually moves to the left. If you see a minus 20, it would move to the right. So let's do an example together. And what we're going to do is we're going to get our friend, the calculator, out to help us. So let me just get that. So stop sharing and share my desktop. And what I want us to do is I want us to first draw the graph of y equals cos x, okay, on the domain, it says here minus 180 to plus 180. So the way we're going to do that, and we did this a lot in the last lesson, is I click on, click on cos, and then I say alpha x close that, go equals equals. Now I'm going to start at minus 180. I'm going to end at plus 180, and my step size is going to be 90. Actually, you know what? Let's make my step size 45. It'll actually be easier to see what's going on if I do that, just for interest's sake. Actually, you know what? Let me go back to 90. I lied. Let me go back to this. So equals minus 180, 180, and let's make it 90. Okay, so not very interesting, I guess. Minus 180 is at minus 1, so that's down here. Minus 90 is at 0. And 0 is at 1. And then over here, what do we have? We have 90 is back down to 0. And then we have another one which goes 180 minus 1. So the basic cos graph is looking, I know my scale is a bit, looks like that. Now, that is the simple cos graph, but I want to compare it to this graph over here. And so I want to give you 2 minutes now to draw this graph, y equals cos x minus 45, using your calculator. And I want you to try and tell me what you see when you compare it to the red graph. Give me a thumbs up if you understand what you have to do. Give me a thumbs down if you're feeling unsure. So I've drawn the cos graph using my calculator for you, and I want you to draw this green one over here using the calculator, and I want you to draw it over this one and see. Okay, cool. Over to you guys. I want to give you some time to use your calculators and put the dots in, and then draw me this graph, and then we're going to talk about what it looks like. I'd love to see some comment about how you're finding it. So does it make sense? What size should we make the step size? I'm curious to know, based on what you're seeing on your calculator, if you make the step size 90, let's see what happens if we make the step size 90. That looks a little confusing. Because instead of having nice, neat numbers, I seem to have quite messy numbers. Give me a thumbs up if you're also getting messy numbers if you make the step size 90. So what I'm trying to check is, can you see how the step size looks a bit messy? I wonder if there's a way we can get around this. I think what we need to do is make the step size smaller so that we can see more clearly what's going on. So let me hit AC and go back, and it takes me back here, and we go equals minus 180 plus 180. What step size should we make it this time? What do you think might help us draw the graph more easily? Yes, I think making it a bit smaller, and because we know it's moving, because it's shifting by 45, I was thinking, yes, so you do that, change your step size to 45, and then what happens? Oh, so it's a little bit easier now. So the minus 180 is still messy, but what I'm seeing is that minus 135 is actually at -1. So where's minus 135? It's going to be over here. So even though, so what we can do is we can use the graph. Let's have a look. So what else we've got? We've got, let me use my mouse actually to help me here. So minus 135, 1, minus 45, 0. So we'll take that here. And see if you can plot your graph using the points that kind of give you a nicer shape there. I'll give you a bit more time because I know this is a bit more tricky and I don't want to rush you. I want everyone to have a chance to see if it makes life a bit easier. So now it's 45, 1. And 135, 0. And what do we have? Okay, that's also going to be messy and it's negative something. So it's like down here somewhere. And what was the very first messy one? So that was also at minus 0.77. So that's about here. So what I've done is I've got these dots and I'm going to start joining them. So let's see what goes on here. Okay. So if I look at the graph, I'll make that 45, and this is at minus 45. What I want to draw your attention to, everyone, is I want to draw your attention to this spot over here. Can you see that the green dot over here, it's almost like it's been moved. The red graph has been moved 45 degrees to the right, and that's how we get the green graph from the red graph. And what I'm trying to show you is it's moved to the right. And that's why, even though there's a negative 45 here, it moves, the whole graph just moves 45 degrees to the right. Okay. Give me a thumbs up if, looking at my drawing, you understand what's going on in terms of moving 45 degrees to the right. And give me a thumbs down if you're feeling a bit confused. Just want to get a feel for what everyone's thinking. Okay. Awesome. So now you've got the basic idea behind a horizontal shift, and you've seen that you can make the step size smaller if you're confused, which is a good trick to do. Why don't I ask you to draw me these two graphs? So I want you to draw for me the graph of y equals tan x and the graph of y equals tan x plus 45. And I want you to do that on the domain. So let's make it again, just because otherwise it takes too long. Let's make it from minus 180 to plus 180. And I want to see if you can do this mainly by yourself. I'll give you some time and see if you can start drawing it, and then I'll come along slowly and start drawing it as you get ahead of me. So we're drawing these two graphs. So y equals tan x and y equals tan x plus 45. Now, some of you may have some predictions. Part of me thinks, I predict that actually there's going to be an asymptote here. But I want to see it on my calculator first, and it gets a bit confusing. So, but I'm predicting there will be one there, and there'll be one at 90. But let's draw it first. So, tan. Okay, so my very basic trig graph is going to look like So let me actually make this the red one. So that is the normal tan graph. But now what I want to know is, how do I draw the tan x plus 45? What is the restriction? So Mbali and Zanele, the restriction is we're doing it on the domain minus 180 to plus 180. And I have just drawn y equals tan x using my calculator. And now I'm trying to draw y equals tan x plus 45. And so I'm just going to go back to make sure my calculator has said that. So tan, then x plus 45. And what I was saying, minus 180, end 180, I'm going up in 45s. And so let me see, minus 180 seems to be at 1. So that's interesting. And then there's an error, which means there's actually an asymptote for the blue one over here. And then at minus 90, I'm at minus 1, which is down here. So this is actually a little bit confusing, but I'm just going to follow the dots because that's why my calculator is my friend. Minus 45, 0. Then I have 0, 1, which is here. Then I have 45 error, which means that actually for this graph, I'm going to have dots there. So this is actually pretty sneaky tricky. So don't worry if you're finding it a bit confusing. I'm also finding it a little bit tough here. My brain is having to work a bit. 135, 0. And then 181, which is here. The good news is I can kind of see the shape that these dots have to go through, because here's my asymptote. And then over here, that gets to there. And then I ran out of space here, so I had to go like this. Now that was a bit tricky, but what I like about it is you can clearly see that the blue graph is 45 degrees behind the red graph. You see how it's like, this is just 45 to the left. And that makes sense to me because x plus 45 means it moves 45 degrees to the left. And so what I love about the calculator is it really just takes you through this process when you're trying to draw it. Okay. Can I have a thumbs up if you followed what I'm doing? Give me a thumbs down if you're feeling confused. I haven't had a lot of feedback today, so I know this is tricky, and I just want to get a feel for the group's feeling. Okay. All right. Well, then, if we feel comfortable drawing all these different trig graphs, before we go off to a break, we are going to have a little look at a graphic interpretation question. So for those students who are feeling unsure, what I'm going to suggest is you go back and watch that early part of the video a little again to help you just get used to how to use your calculator. And so all you need is a bit more repetition. But because I want to also get through some graphic interpretation today, I think I'm going to move on for now. Okay. So what does a typical graphic interpretation question look like? So this is from a past exam paper, and I don't want you to worry about all the questions. All I want you to try and work out for me before we have a break is I want you to think about 6.1 and 6.2. So if you look at this thing says f of x is cos x. So that's this yellow one here. And then it says that g of x is sine x plus b, and that's this one over here. I want you to work out, can you work out the answers for 6.1 and 6.2? see if you can have a go at that. And some of it's going back to earlier lessons, some of it based on today's lesson. I'll wait a moment or two for anybody who wants to put their hands up or for the answers to come in the chat. So if we look at B, the one hint I'll give you about B is it's got to do with the horizontal shift. Because remember, it's plus B there, so it's got to do with the horizontal shift of the green graph. Then the period of G, that has to do with the basic sine graph. Who would like to come on and maybe ask a question? I'll give you a little hint. What do you think that is showing you? Doesn't it feel a little bit like this graph has been shifted, the normal sine graph has been shifted in that direction? So to have a quick look at it, normally when we draw the sine graph, it looks like, oh wait, let me do it again. Normally the sine graph starts here and does that. But it feels like it's been moved down to here. So how would we work out the value of B? Mesh and Marisa, I think you're onto something. So if I want to move my whole sine graph 30 degrees to the left, it has to look like this, x plus 30. And so what does that make B? It makes B equal to 30. Now that's the one way we could do it. The other way is we could take the equation and sub in something. So let's say we have this equation. Can you see that there is a point on the graph? Let's have a look. What point should we use? Okay, Michelle, you've got that there. So what you could also do is you can see this point on the graph here. So 0.5, or you could use the point minus 30, 0. And if you put a 0 in here, and you put a sign there, and then you put a minus 30 plus B, you could also try and solve that trig equation. But I think for most of us, the simplest way to spot the shift is just to look at where does the sine graph normally start, and where does this graph, where has it been moved to? And it's been moved to the left by 30. And so if I want to move to the left by 30, then my graph will just be, it'll basically be sine x plus 30. All right. Now, what about 6.2? What is the period of, can I do 6.3? I'm going to do 6.3 mesh after the break. We're just going to have a break first, and then I'm going to come back. We're going to finish this question. What do we think the period of the graph G is? Has the period even changed from normal? Who feels like they want to give an answer here? I know someone wants to shine brightly. So remember, Morgan, the period is one complete cycle of the graph, right? So if you think about it, this is a sine graph. What is the normal period of a sine graph? How long does it take a sine graph to go up, down, down, up? And I feel like because the period of the graph hasn't changed, there's no number in front of the x, it should be whatever the normal period of the sine graph is. So, Morgan, I agree with you. So the period of this graph, because it's a sine graph, and the only thing that's changed to it is it's had a horizontal shift. The period has not changed. And so the answer for 6.2 would be that the period of the graph G is going to be 360 degrees. Now for bonus points, before we have our break, what is going to be the period of the graph F? The graph F is this one over here. What's the period of F? This kind of goes back to our previous lesson, but I want to just throw it in there. What's going to be the period of the graph F? Yep. F is a normal cos graph. What's the period of a normal cos graph? It's just 360. And so when they ask these questions, we have to know whether or not we need to know the normal period of the graph. So for sine and cos, the normal period is 360. For the tan graph, the normal period is 180. And then if nothing has changed, if the letter in front of the variable hasn't changed, then we just give the normal period of that graph. Okay. All right, everyone, I've been working you hard. It's now time for some brain break. And so can I have you please turning on your cameras and standing up with me, because we need to just let ourselves unwind and just take a moment for ourselves. So stand up nice and tall, and see if
Please turn
you
on
can
your cameras, guys. Let's see your
stand on your
faces.
toes and see if you can stretch and touch the ceiling. You should feel your calf muscles, you should feel your stomach muscles and your shoulder muscles, and you should even struggle to balance a bit. See if you can do that. Oh, there we go. See if you can touch the ceiling. Such a good movement exercise. Like you have to balance your core and your calf. Okay, then let's just shake out our arms. Let's just loosen up a little bit. So pretend that you're made of rubber or jelly and just kind of shake your arms around a little bit. Sorry, my collar is coming out here. And then let's shake out your legs. So shake out the legs. And then let us just do a little twisting. So initially just a little bit, not too much rotation. And then as you start to loosen up, your body should go a little bit further. And then let us do a little stretch. And if you have a favorite stretch that you want to add to the routine, please don't be afraid to share. I'm always open to suggestions. And then let us do some heart rate stuff, and let's do jumping jacks. I know it's a classic, but you can't beat them. So let's do 15 jumping jacks, and we'll start in 3, 2, 1, and let's go 1, 2, 3, 5, 6, 7, 8, 9, 12, 13, 14, 15, and sit down. And I want to know from you guys, can you find me an answer to one of these Math 24 cards? So you don't have, I just want to make sure we get one of them today. So can you make 24 with any of these 4 cards? Who feels like they can do it?
Who will be first?
Dudu has said 8 minus 4 is 4, 8 minus 2 is 6, and 4 times 6 is indeed 24. So let's have a look. That should be 4, that should be 6, and then that gives you 24. Awesome, 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 awesome.
Nicely done, Dudu.
Anybody else want to shine brightly? Anybody feel like they have an alternative answer to that, or an answer for another card? Okay. So Lutando has said, what about 4 times 2 plus 8 plus 8? So 4 times 2 plus 8 plus 8, which would be 8 plus 8 plus 8, which is indeed 24. Yes, Lutando, that is fantastic. Well done.
Well done, Lutando.
Yes. Okay, so let us go back to our lesson that we were doing. Now, things are starting to get a wee bit exciting. So before we really dive into this question, I want to just remind you of some of the basics of this topic. Okay, so every trig graph has 4 different changes that can happen to it. So we spoke about that at the beginning of the lesson, but we also have ideas about things like the range. We also need to know about the domain of a graph. We also need to know about intersection points. These are all ideas that will always come up with functions. And so if you are feeling stuck with something as we go into these interpretation questions, I encourage you to ask a question in the chat or raise your hand. Okay, so now we're going to do this next one together. Write down the value of x in the interval minus 180 to 90. Now, first of all, let's just see where minus 180 to 90 is. So minus 180 to 90 is just the strip of domain here that is shown on the graph. And they want to know what pieces of this x-axis is this statement going to be true for. Now, the thing is, the way it's written is a little bit sneaky. What I think would be an easier way to write this, and this is something you do learn to do, is that if they give you a statement, I could have also written the statement as where is f of x equal to g of x? So where, for what x values on this line, is the graph f equal to the graph g? So I want to give you a chance to put your answers in the chat or raise your hand if you'd like to say them. What are the values of values where the f graph equals the g graph if you look at this drawing here? Aha, Mbali and Zanele, I think you spotted this thing over here. And so I can confirm that indeed one of the answers is going to be x is equal to minus 150. Are there any other answers? Okay. So the answers are flooding in here. And another answer that's being given is 30. So let me go to 30. And indeed, f does indeed intersect with g at 30. And so another answer here will be x is equal to 30. Yep, that's not so bad. Okay, well done. Well done. So let's have a look at 6.4. For what values of x in the interval minus 180 to 90, so that is the same interval that we spoke about up here, is the sine of 90 minus x greater than g of x? Now, again, there's a little trick. Does anybody know what sine of 90 minus x is the same as? You could use something called the reduction formula. What could you make the sine of 90 minus x the same as? Who can remember what the sine of 90 minus x is? Okay, it's not even minus cos x, it's just cos x. Yes. So the sine of 90 minus x is cos x. So what this question over here is really asking is, when is cos of x greater than g of x? But I've spotted something else. What is cos of x? Cos of x is just f of x in this question. So what they're really asking is, when is f greater than g? So if we look at this graph, for which x values is the f graph above the g graph? So who would like to tell me, if they look at the drawing, where is the f graph above the G graph? Between which X values? Okay, now be careful here. I was thinking, if I look at the F graph, the F graph is like this pink one, right? So there's the pink graph. And then what they're saying, what the question is asking is, when is the pink one above the other one? So let's put the blue one in. Blue can be G. Do you love my colors? It looks to me like the pink one, or F, is above the blue one. Between here, they're equal, right? So they can't be above each other when they're equal. But it feels like it's between these two parts. So Mdudu has suggested between minus 150, which is here, and 30 would be the answer. And I think I agree with you. Now, the question is, how would I write that? And there's two ways I can write it. The one to write it is like this. So minus 150 to 30. Or I could also write it like this. Now, that is a tricky question, but the moment you understand how to do this difficult part, so this is the hard part, knowing that this is cos x and cos x is the same as f of x, and that is tricky. So I'm not going to lie to you that, that is a tough question. Give me a thumbs up if you feel like you understood my explanation with the pink and the blue. All right. So 6.5, I think you guys can try and do 6.5 by yourself. It says the graph of H is obtained by shifting F 3 units upwards. Determine the range of H. So this is saying, look at the graph F. So F is, which one was F? F was the purple one. So let me get my purple. So F is the purple. And it's saying, look, let me even get rid of some of this other stuff because it's just distracting for me at the moment. So it's saying, look, H is obtained by shifting F upwards by 3 units. What is the range of this new graph H? Who would like to give this a go? When we talk about range, we're talking about the Y values that are relevant. But remember, we're taking the graph of F and we're shifting it upwards by 3 units. What's that going to do to the range? At the moment, the range for F looks to me like it gets down to -1 and it gets up to 1. That feels like the range in which it's sitting. I want to know, if you talk about a graph that's been shifted 3 units upwards, what's the range of that graph going to be? And I'm going to wait for some answers in the chat or for someone to put their hand up. So let's have a look. If I took this -1 and I went up by 1, I would get there. If I went up by another 1, I would get there. And remember, I have to go up by 3 units. So it feels like this new graph, 8 of x, which I'm getting, it is going to be the same as cos of x plus 3. Now, its lowest value is going to be 2. Because look at how I moved this up by 3, I got to 2. Now, the question is, what is my highest value going to be? Now, remember, the range was how many units? The range was basically just 2 units. It went from -1 up to 1. So the range is 2 units. So if this is now my lowest part, I also need to be able to go up by 2 more. It feels like it should be between 2 and 4. And in this case, I should actually be including my endpoints. So instead of having circular brackets, because I include both 2 and 4, it should look like that. Or I could say y is greater than or equal to 2, less than or equal to 4. Yes, Chuma, Mesh, Tamilo, Neo, Munduru, you are looking very good there. Okay, so that is a graphing interpretation question where we have to figure out the equation of the trig graphs. I want to do one more tonight, so let us move on for now. But very well done, everyone. I liked what I was seeing there. Okay, let me do rather. What should I do? Should I do this one? No, let's do. Okay, let's do this one. Okay, I want, now again, we're not doing just the stuff we've done tonight. We're doing some stuff from earlier in the series. I want you to try and find me the value of A, and also try and find me the value of B. And if someone's willing to come online and explain to us how they find it, that would be great. Otherwise, I'm going to give you some time before we suggest the answers. What is A talking about? What is A changing? What does A change? And what does B change? Is what I want to know. And then I want to know what A and B actually are. Who would like to share some wisdom, share their thinking? So Tigabatsu has said A changes the amplitude of the graph. You are absolutely correct. Normally the amplitude of the sine graph is 1. And it feels like, and the range of the sine graph is normally between -1 and 1. This looks a bit different to me. So what do we think A is going to be? So A is going to have the value of 2, because you can see that the sine graph goes up by 2 and then down by 2, then down by 2, then up by 2. So A is indeed equal to 2. Now, what is B going to be equal to? So Tando, watch out. For amplitude, we only talk about a positive value, like it goes up by 2. Okay, so it wouldn't be A equals 2 or -2. -2 would force the graph to be down here. So it's just A is 2. Okay, now Tigavatsu, watch out. B doesn't actually shift the graph. What B changes, it changes the period of the graph. So the value in front of the X, this changes how quickly we get a full tan graph in play. So if we had Y equals tan X plus B, then that would be a horizontal shift. But this graph actually has a number in front of the X. And if you go back to the previous lesson, you'll see that what we do is, normally, what we do is the normal period of the tan graph is 180. But then if there's a number in front, we divide the period by whatever that number is in front of the variable. Now, or maybe we can even, whatever that number is. Now, we don't know what that number is, but maybe we can work backwards, because what is the period of the tan graph we see here? Does anybody have any ideas about what the period of this tan graph may be? So I think if I look at this, normally a full tan graph can happen in 180 degrees. But this tan graph, a full tan graph, fits in 360. Now, it is a little bit confusing, but the only number that I can divide by, so we can even make this letter, we can make this X if we want, or we can make this letter like y if we wanted. We need a number that when we divide 180 by this number, it gives us 360. And the only number that when you divide by that doubles it is going to be, and this is a bit tricky. So if I go 180 is 360y, and I bring the 360 to this side, that number is going to be a half. So go back and have a look at the previous lesson if you're feeling confused. Y is going to be equal to a half. I mean, sorry, not y. The number in front of the x is going to be equal to a half. And so what this should be is y equals tan a half x. And what that does is it takes the normal period of the tan graph, and when it divides by a half, I get 360, which matches this drawing here. Okay, now I want you for the last question for today. We're not going to have time to finish this. What is the value of the point P, and what is the value of the point Q? That's going to be our last question for today. So what is the value of the point P? What is the value of the point Q? Stay with us, people, indeed. So we're trying to figure out what are the coordinates of the point P and what are the coordinates of the point Q. If I look at P, it looks like it must have 120 in front. And for Q, what's this going to be? 10. That looks like it's going in 30s. So 210, 240. Okay, but now the problem is, how are we going to figure out what Y value goes with this 120? We know that that's going to be in line with something up there, but how are we going to find that Y value? And the same here. We know that this is in line with 210, or not 210, it's 240. How do we know what value it's going to be in line with? Can't we just put it into this function? So don't we know what the value of this f function is? We know that this function is just y equals 2 sine x. So I'm going to take my 120, and I want you to tell me, what is the value of 2 sine 120? So put that in your calculators, and what do you get for 2 sine 120? Okay, so you should get root 3, yes. Square root 3 or 1.7 something, hey? Or 1 point, what is it, 1 point something? Yeah, 1.73. And then using the same idea for the next one, what's going to go with 240? Yeah, and it's going to be minus 1.73. All right, everyone, that was great. We're going to finish off now.